In this integral, here we have evaluate integral x squared over radical 16 minus x squared dx. This question, we will solve it by especially trigonometric substitution. Because we have radical 16 minus x squared, so it's the same as radical a squared minus x squared. And in this case, as we remember, we have this substitution, x equal a sine theta with theta between minus pi over 2 and pi over 2 as a closed interval. So here in my question, a equal 4 because a squared is 16, because also here we talk about a greater than 0. So I will start from x equal 4 sine theta with theta exists in closed interval from negative pi over 2 to pi over 2. Now dx equal 4 cosine theta d theta. I will back now to my integral. I will name it by I. So I equal integral x squared, it's 4 sine theta squared, so it's 16 sine square theta over radical 16 minus x squared, which is 16 sine square theta, times dx, which is 4 cosine theta d theta. Now 16 sine square theta over. In this radical here in the denominator, I will take 16 as a common factor, and I will take it outside of radical. So radical 16, it's 4. And inside radical, 1 minus sine square theta, 4 cosine theta d theta. Now, what about 1 minus sine square theta? 1 minus sine square theta, I will replace it by cosine square theta. Radical cosine square theta will give me absolute cosine theta. But because theta, it's between minus pi over 2 and pi over 2, cosine theta here all the time is positive. So absolute cosine theta will give me cosine theta. So radical 1 minus sine square theta is radical cosine square theta, which is equal cosine theta. So here I will have integral 16 sine square theta over 4 cosine theta times 4 cosine theta d theta. I have translating from here cosine theta 4 with cosine theta and 4. So it's equal integral 16 sine square theta d theta. To solve this integral, I will take 16 outside. Sine square theta, it's 1 minus cosine 2 theta over 2 as an identity. After that, 16 divided by 2, it's 8. Integral of 1 is theta, because here d theta, minus integral cosine 2 theta, it's 1 over 2 sine 2 theta. 8 distributed to the bracket, so 8 times theta, it's 8 theta. 8 times 1 over 2, it's 4 sine 2 theta plus c. Actually, here it's plus c also. Okay. Now, what about sine 2 theta? Sine 2 theta, from the identities which I memorized before, it's 2 sine theta cosine theta. That means 8 theta minus 8 sine theta cosine theta plus c. This is the final result of this integral, but in terms of theta. My question is in terms of x, so I must change the term theta, the term of x. Now I will bring the right triangle and work on it. So this is my right triangle. This is my angle theta. As I know before, sine theta equal x over 4. If I back the first step here, x equal 4 sine theta. So sine theta equal x over 4. So the opposite of theta is x, and the hypotenuse is 4. By Pythagoras theorem, I can find the missing side here. It's radical 16 minus x squared. From this triangle, now I can find cosine theta. Cosine theta is the adjacent 16 minus 6 squared over the hypotenuse, which is 4. Now I will back to my answer here. So it's 8 theta. Theta, it's sine inverse x over 4. Why? Because sine theta equal x over 4. So theta equals sine inverse x over 4. Minus 8 times sine theta. Sine theta, it's x over 4. Times cosine theta, it's radical 16 minus x squared over 4 plus c. So now I have 8 sine inverse x over 4. 4 times 4 is 16. 8 over 16, it's 1 over 2, x radical 16 minus x squared plus c, and this is the final solution for my question. I will minimize the page if any one of you want to take a picture for the answer. So it's here now for all. That's it.